Welcome to this puzzle session. Here is the problem. A man eats at least one apple every day. If in 30 days, 30 consecutive days, basically a month, he eats a total of 45 apples. So exactly 45 apples have been eaten in 30 days. We want to show that he eats exactly 14 apples in some sequence of consecutive days. So it may be that there is some one particular day where he eats 14 apples, a bit much. Or maybe in 2 days he eats a total of 14 apples, 2 consecutive days, not just some 2 days. Or in 3 consecutive days or something. But there must exist a sequence of consecutive days where he eats exactly 14 apples. Which is what makes this puzzle very interesting, this exactness of 14. Okay? So we will be discussing two solutions of it. And as usual, you're encouraged to pause the video and find your own solution. With that, let us continue. So first solution, it's a very slick and short solution. So let us say A1, A2, A3 up to A30 be the number of apples that have been eaten in the 30 days. So on day 1, so many apples, then day 2 and so on day 30. All right. Note that AI is at least 1 for all I. Why? Because it was given that he eats at least one apple every day. We also know that the sum of all the AIs is 45 because he eats a total of 45 apples. Okay, define BK as the sum of the first K AIs. So that is BK. And this is defined for each K in 1 to 30. Okay, so just note that B30 is 45 because B30 is the sum of all the AIs. As we already noted, it is exactly equal to 45. So what does the problem ask us to show? So the goal is to show that there exists I less than j such that bj minus bi is equal to 14. Right? So just realize that this is what the problem asks us to do. All right. So now consider the numbers. So we have written down 60 numbers. These are the 30 numbers that we generated. And then these are the next 30 numbers which are obtained by just adding 14 to each of these. Okay. So as we already know, this is 45 and hence this is equal to 59. So this is 45 and this is 59. All right. So these are total of 60 numbers. These are 60 numbers and each number is between 1 and 59, both inclusive. So these numbers lie in the range, so these numbers lie in the range 1 to 59, right? But there are 60 numbers, so some 2 must be equal. So some 2 of these numbers must be equal. This is the pigeonhole principle or common sense. But no 2 of these numbers are equal. Why? Because each AI is at least 1 and hence this is an increasing sequence. B1, B2, B3, this is a strictly increasing sequence. So no 2 numbers here are equal. Similarly, by the same reasoning, no 2 numbers here are equal. But since 2 of the numbers must be equal, we must have some guy here is equal to some guy there. So there exists I and j. So thus, there is some pigeonhole principle reasoning which we have said in words. We will not write it down. So thus, there exist I and j in 1 to 30 such that bi plus 14 is equal to bj. So some guy from here, which is written as bi plus 14, is equal to some guy from there. Now, clearly I cannot be equal to j. In fact, this forces that I is strictly less than j, because b1, b2, b3, this is a strictly increasing sequence. So this just forces that I less than j, and we are done. So between the day I exclusive, so basically from day I plus 1 up to day j, the guy eats exactly 14 apples. Very nice solution. But I also want to discuss another solution. So as in the previous one, we will write A1 up to A30 to record the number of apples eaten on each day. And BK is defined as before. The sum of AIs up to A, starting with A1. So that's BK. And now recall this number theoretic fact, which is also a consequence of the pigeonhole principle, that if n is a positive integer and we have n plus 1 numbers, n plus 1 integers, then there exist distinct I and j such that bi minus bj is divisible by n. The proof of this is very simple. Just record the remainders modulo n. Since there can only be n distinct remainders while there are n plus 1 numbers, some two numbers must leave the same remainder, and therefore you get that their difference is divisible by n. So if this is not completely clear, just take this as an exercise. This is a very simple level 1 problem, if I may say so. Okay, so we will use this. So what we will do is the following. We have this 30-day period. This is day 1. And in the middle, hopefully this is the middle. So this is day 15. This is day 15 and this is day 16. And this is day 30. Okay. Now, we have 15 numbers here, B1 up to B15 corresponding to this. We have these 15 numbers. So what we know is that by the previous thing, we know that bi minus bj is divisible by 14 for some distinct I and j. So what that means is that there is some sequence of consecutive numbers, some sequence of consecutive days here where either 0 apples were eaten or 14 apples were eaten or 28 or 42, basically multiples of 14. But note that 0 apples cannot be eaten. Why? Because they are different I and j's. Bi minus bj is considered for different I and j. And since b1, b2, b3, this is a strictly increasing sequence as noted in the previous solution. It's a strictly increasing sequence simply because each AI is at least 1. So 0 apples cannot be eaten in this range of days. So either 14 apples or 28 apples or 42 apples and so on. So many apples have been eaten in these range. One of these numbers have been eaten in this range. Similarly, by the same reasoning, there is such a consecutive set of days here where either 14 apples or 28 apples or 42 apples have been eaten. Okay. Now, if this number were 14, we are done. Or if this number were 14, then we are done. So by way of contradiction, we may assume that none of those numbers are 14 and hence they start with 28, both of them, 28 or 42 and so on. But then the total number of apples that have been eaten here plus the total number of apples that have been eaten here, they sum up to at least 56 because 28 plus 28 is 56. This contradicts the assumption that 45 apples were eaten because 56 already exceeds 45. So that doesn't work. All right. So that's it. I mean, that is the solution. And with that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.